Okay guys, welcome back. I know that last lesson was crazy and it's not as bad as it sounds. We're going to do a couple of questions here and make sure we can calculate the VA, the power, the VARs, and the phase angle of this weird circuit right here. Now the funny thing about this is we don't know anything about it, okay? It says a 600 volt 10 amp load is running at a power factor of 0.71 and it's expecting us to calculate all these things about it. And we don't know if this circuit is series or parallel or combination, and the good news is it doesn't even matter because power phasors are always going to work for every kind of circuit, okay? When we were doing our LC series, we had to use impedance phasors, and then when we did parallel, we had to use current phasors, and there was all these rules about it. With power phasors, they work for every single kind of circuit. It never matters whether it's series, parallel, or combination. And so that's nice. We're just going to see if we can figure this out, regardless of what's going on with the circuit. Now, it says 600 volt 10 amp load is running at a power factor of 0.71, and it wants us to calculate these three things. And, I don't know, doesn't seem like we have enough information, but as soon as you recognize that it is a power question, okay, you should endeavor to draw a power phasor diagram. Now, I know my power phasor diagram is going to look like this. And by the way, guys, well, we'll get into it later, okay? This is going to be my power phasor diagram. It is always going to be a right angle triangle. My true power is always going to be here. My reactive power is always going to be here. And my VA is always going to be here. And the power factor, actually, you can just stick it in right here because it represents, the relationship between this and this. So here's my power phasor diagram, and there's an angle here, which I could calculate, and we will eventually, okay? But for right now, I'm just going to put my power factor right in there, and we're going to see if we can solve these three sides. Now, if I've given you a voltage and a current in the circuit, that's fantastic, guys, because we know that the VA in the circuit is E total times I total. And if I've given you numbers like this, it's as if I walked up to this machine, whatever it is, put my voltmeter on it, wrote down 600 volts, clamped on my ammeter, write down 10 amps. Those are going to be total values every single time, okay? So if this is some sort of RL series circuit or something like that, it'd be really hard to figure out the voltage dropping across the resistor and the current through the resistor. It'd be really easy to figure out the total values, and that's what we've given you here, okay, guys? We've measured them, and they're given. What that means is I can calculate my VA. If I've given you the voltage and the current of the circuit, guys, and I don't care what verb I use here, I could say it's a load, I could say it's a motor, I could, what noun, I guess you could say. I could say it's a, whatever. It doesn't matter what word I use here. If it says a voltage and a current, multiply them together because that'll get you the VA. And so that's what we're going to do here. E total is 600 volts and I total is 10. So this is going to be 6,000 volt amps. Okay, guys? So one side done. Now, next up, let's see if we can calculate the power in the circuit. Now we have a few formulas at our disposal, and I wrote a couple down right over here, okay? We know that P is equal to ER times IR. We know that VARs is EXL times IXL. We know VA is E total times I total. We just applied this one. Van Andel, I don't have enough information to apply these two, I don't know what it is. But there's another formula, that's this one right here, and that one is going to be the one that we're going to use, okay? If I don't know anything about the circuit, and I don't know these voltages and currents, I always have this one to fall back on. So let's write that formula down here. The power factor is always going to be P over VA, and if I transpose that, my power is going to be my VA times my power factor, and it always will be. I mean, this is how this gets transposed every single time. What that means is I can calculate my power. It is going to be my VA, 6,000, that I just calculated, times the power factor was given to me in the question, okay? And we're going to do that here for a second. 6,000 times 0.71. Looks like it's 4260 watts. All right, guys? Now, Notice that it's smaller than this. It needs to be, okay? And so I've seen students transpose this incorrectly, okay? And then they end up with P is equal to VA over the power factor, and then they take 6,000 and divide it by 0.71. You'll end up with a big number here, okay? And there's no way that the true power in the circuit is more than the VA. The VA is always going to be the biggest number. So I correctly transposed this, and I've correctly calculated true power. The last thing I'm going to do here is calculate the VARs, or not the last, but the next thing. And look, it's a right angle triangle, which means that the VARs is going to be the square root of, this is Pythagorean theorem, 600 squared minus 4260 squared, right? We're solving for the short side here. All right, guys? So 6,000 squared minus 4260 squared equals root equals. It looks like my reactive power is 4225 VARs. Okay, so we've got some of these things calculated here. Let's write this one in here. 6,000 VA. Okay, 4260 watts. True power always measured in watts. 4225 VARs. Okay. The last thing we have to do is calculate the phase angle. Now I got a triangle here. I can calculate the phase angle a bunch of different ways. I could go opposite over adjacent, inverse tan. That would be perfectly legitimate. 4225 divided by 4260. Inverse tan, that would work. But we know also that the power factor is equal to the cosine of the angle, which means the angle is always going to be, the power factor shift cos. Okay, so, pick your poison. How do you want to calculate this phase angle? Maybe I'll calculate it both ways just to show you that they'll both work. According to this formula, the angle should be 0.71 cos to the -1. Okay, so let's do that here. I think I have to hit shift cos 0.71. According to that, it's 44.76, degrees. 77 maybe. That's fine. Or the angle should be the opposite. 4225 over the adjacent. 4260. Inverse tan. Okay, now I'm using opposite and adjacent, so I got to use tan here, guys. And so it's 4225 divided by 4260 equals shift tan equals, okay, 44.76 degrees. Okay, so I don't care which one of these you use whatever works for you. If you're used to using opposite and adjacent, opposite's going to always be VARs, adjacent's always going to be power. Okay, so pick your poison, use whichever one you like. I don't know. Stick around for the next video. We'll try a little bit of a different one. Okay, guys?